Okay, so looking at frequency distribution graphs, we're just going to talk about the different types and the key aspects of them. So the first one we're going to look at is a frequency histogram. This is a bar graph that represents a frequency distribution. Our three important characteristics is that we have the horizontal scale, or the x-axis, is quantitative and measures measures data entries. Number two is that the vertical scale, or the y-axis, measures frequencies. And the key thing is that consecutive bars must touch. And this is why most commonly we use class boundaries to graph. Okay, but you can use either class boundaries or midpoints. And we're going to look at examples of both. So this first example from your book shows using the class midpoints. So here you can see that we have a broken axis, which means that we have a jump from 0 to the first midpoint of 172.5. And each of our bars are touching, but the key thing when you use your midpoints is notice that the tick mark to represent the midpoint is in the middle of the bar. Okay, that's the most common missed thing when using midpoints. So be careful about that. Make sure that you are labeling both the total graph and both of your axes. Okay. And then notice your bars just represent the frequency. So for our first class, our frequency was 3, so the bar goes to a height of 3. Okay. We also can use labeling with class boundaries, which is what I think is the easiest, because each of your boundaries of your class are what bind that bar. So you don't have to remember to label the midpoint in the center. By using the boundary, it just represents the left and the right, and it matches the table a lot easier. Okay, so you can tell with our first one, we go from 154.5 to 190.5, the height of 3, which matches that first class. Again, make sure you're labeling your graph as a whole and both of your axes. Also, you notice the break again to represent that jump from 0 to the 154. Okay, our next graph is a frequency polygon, and this is a line graph that emphasizes continuous change in frequencies. So here, our horizontal scale is quantitative and it must include midpoints. This is the one graph that has to have midpoints as your horizontal axis. The vertical scale is going to measure frequencies. And the other key thing is the graph starts and ends on the x-axis. So if we look at this, okay, this is our same data that we looked at the previous histogram. Notice our first class, the bar goes up to 3, and that's where that point is at. Okay. In order to find these midpoints, we're going to subtract by that class width. Subtract, so we're going to do midpoint, let's say first midpoint, minus the class width. And then to find our upper midpoint, we're going to do our last midpoint. Plus the class width. Okay. Other than that, your shape of your graph really does match the histogram. A lot of times you'll see actually a frequency polygon stacked on top of a histogram graph to show the differences between the two and the similarities. Okay, relative frequency histogram. So a bar graph that represents a relative frequency distribution. So your horizontal scale is quantitative and measures data entries still. But here, instead of using midpoints, we can go back and also use class boundaries. Then our vertical scale, or y-axis, is going to measure the relative frequencies. And then consecutive bars must touch. So what you'll notice is this graph looks almost identical to the graph of the frequency histogram. The only difference is that you're labeling based off of the relative frequency. The height of the bars should all be the same. You're just changing that scale. And again, make sure you're labeling your x-axis, your y-axis, and the whole graph. Okay, and our last one is a cumulative frequency graph, which is also called an ogive graph. And this is a line graph that displays the cumulative frequency of each class at its, let's say, upper class boundary. Okay, so our characteristics. This one is a little bit more precise. The horizontal scale consists of only the upper class boundaries. The vertical scale measures the cumulative frequency. The points plotted represent the upper class boundaries and their corresponding frequencies. And here the graph should start at the lower boundary of the first class, showing that we have a cumulative frequency of 0, and should end at the upper boundary of the last class, and that cumulative frequency is equal to the sample size. So here we have our table, and we have our upper class boundary listed. So our first class, the boundary went from 154.5 to 190.5. Okay, so notice that's why here we're starting at 0 at 154.5. Okay, and then we go up with our upper class boundaries and represent that cumulative frequency we get from our table. Okay, remember, whenever you're looking at an ogive graph, this tells us our sample size. Okay, our sample size of 30. Okay. And then that is all.